All right, today we're going to talk about how to solve trig equations. There's going to be a couple of techniques that you can do, so you can kind of read through all that here, and then maybe pause the video so you can copy these over here. But some of the main ways we're going to do that, we're going to isolate the trig expression. So that means, like, on this next one here, see if we can get to where we write tangent once. Sometimes you might need to take the square root or square both sides. We'll see some where you have to factor out something and then set your factors equal to 0. Some problems towards the end of the notes we're going to solve with multiple angles, and then I guess sometimes you can rewrite some of your stuff, like maybe you can use your identities to simplify and rewrite something as a single trig function. So I think we see a little bit of everything here on that. So let's go ahead and start here. This first one here, I'm going to try and isolate the tangent of x. So, and this is different from verifying. So we are like going to be told that this is actually true. So we're not verifying. So we can work with both sides. So I'm going to subtract the tangent from both sides. And then since you have 2 tangent x and then minus 1 tangent x, you're left with 1 tangent x. I'm just going to write tangent x and then minus root 3 and then equals 0. Next, after that, I'm going to go ahead and add the square root of 3 to both sides. That's going to give me that. And then from there, now we need to just go figure out on our unit circle where is, tangent of what angle gets us square root of 3. If you're having trouble finding that on your unit circle, that's because tangent's the ratio of the y to x. So what I'm going to do here is I'm going to write that over 1 right there, and still those, there's not a y value of root 3 and there's not an x value of 1. So to kind of manipulate this is my little trick here. You can put both of these here over 2, and then we can try and actually find a y and an x value that kind of match up with that. A y value of root 3 over 2 and an x value of 1/2. I believe that should be pi over 3. So we'll say x can be pi over 3. And then there's going to be another one as well. So I think, because you could have like the negative over a negative right there. So that's going to be in the quadrant 3 right there. So that's going to be 4 pi over 3. Now, depending on how I ask you to answer this question, sometimes I'm going to say put all answers between 0 and 2 pi. And then sometimes I'm going to ask you for the infinite answers, the infinite number of answers. And since I didn't put this part here, 0 to 2 pi, we do see that come up here, I think on the next page. But since we don't have that, we're going to put the infinite answers, so that's where we're going to do like our plus pi n thing. So if we think about, the period of tangent, really the period of tangent is pi. So you could just go take one of your answers, put pi n being an integer. And actually, if you add pi in, if you add 1 pi in right there, that gets you 4/3 pi. So that will take care of that one answer, essentially. So like you'll have that, you'll have the 4/3 once you add 1 pi in, and then you'll get your infinite number when you keep adding your pi in. So really that's going to be your answer right there. If I say from 0 to 2 pi, then you would put this first answer and that second answer, and that would be all the ones through 2 pi. So that's essentially what you do there on that. So let's try out this next one here. This next one, we're going to try and isolate the sine squared. We'll start that by doing minus 1 on both sides. That's 4 sine squared of x equals 3. And of course, we'll divide and get 3/4. And then this one, we're actually going to square root both sides. And don't forget, when you square root both sides, you're going to have to put plus or minus. Okay. And actually, I'm going to square root those numbers individually here. So here, let's write this sine of x and then equals plus or minus the square root of 3 over square root of 4. Square root of 4 obviously is going to be 2. And then now we're going to figure out sine of what angle gets us the positive root 3 over 2 and then the negative root 3 over 2. So that'll be at a couple of different places right there. Sine is typically tied to the y values on the unit circle, so I think that's going to be at pi over 3. So one of your answers will be pi over 3. I guess there would also be 2 pi over 3. Those would be both of the positives. And then you'd also have 4 pi over 3. and then 5 pi over 3. Now, if I asked you for the 4 answers between 0 and 2 pi, that would be all 4 of them right there. If you want to go and do the infinite number of answers, you need to do the plus pi n thing. And think about the period of sine. Typically, the period of sine is 2 pi. So I think on the textbook, they'll just put plus 2 pi n to each one of these. I guess you could, in a way, consolidate some of these down here. Because if you add 1 pi n, if you add 1 pi to the first answer, you'd get that second answer. So you could write it like that, or you could write it as pi over 3 and then plus pi n, and that kind of covers that one and that one right there. And then you would also put, I guess, the 2 pi over 3 and then add another pi n, and that'd get you from this one to this one right there. So that's the way I'd probably prefer it there, but I do know the textbook, when they list out their answers, I think they just put all 4. Putting all 4 like that, it takes out a little bit of the thinking out of it, so you just get your 4 answers and then just add on your period, and then you should be good there on that. So there's a couple of those there. Next coming up here, now they're only going to do solutions from 0 to 2 pi, so we don't have to do that extra thing. What makes this one here a little bit different is you got multiple trig functions going on. So what I would like to do here on this one is I'm going to actually subtract over this 3 cosine of x, and then call that equal to 0. Then from there, I'm actually going to take out a cosine, since being multiplied there. So take out a cosine or undistributed cosine. That'll leave you with sine x and then minus 3. And actually, the cosines will cancel, so it's just sine x minus 3. Okay, now what we're going to do is do the zero product property. This just says here, if something times something equals 0, either that first thing is equal to 0, so cosine of x is either equal to 0, or sine x minus 3 is equal to 0. So we're going to set those up. Cosine of 0, that actually, a cosine of x equals 0, that happens at the angles of pi over 2. And then actually that would be 3 pi over 2 as well. And then this next one here would be sine of x equals 3. And that's actually outside of the output values. Like there's nothing you can put, no angle you could put in, and then you ever get 3. So this part here has no solution to this part right here. So your true answers here, the only answers to this here is pi over 2 and 3 pi over 2. If you want to get real fancy and add on the period to those to get your infinite answers, you could put pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n as well. That would get all your answers. But since we are between 0 and 2 pi, those are the only 2 answers that are going to be like that. Okay, this next one right here, what we're going to do is, this one's actually kind of set up like a trinomial. It's going to be something we're going to factor. It's actually going to factor real similar to x to the 4th plus x squared and then minus 2. Essentially, we find two things that multiply to negative 2 that add up to the positive 1. And then you need x squareds out in front since you have x to the 4th. So I think this would be plus 2 and then minus 1 like that. So we're going to do kind of the same idea here. So this first one here will be cosine squared of x times cosine squared of x. For the front right there, that would FOIL back in. Now we need things that once again multiply to negative 2 that add up to positive 1. So that would be positive 2 and minus 1. And then now you can set your factors individually here equal to 0. We can go cosine squared of x plus 2 equals 0. We could then subtract 2. And then we can square root both sides. And actually you can't really square root a negative. So we kind of toss that out. We're not going to really deal with imaginary answers here. So that one kind of gets tossed out. This other one here, yeah, you can go cosine squared of x and then minus 1. It's kind of skipping a step there for a second. Minus 1 equals 0. You can add your 1 to the other side, and then you can square root both sides. And since you are square rooting both sides, you do need to put plus or minus 1 right there. Now, as far as like an x value for positive 1, that would just actually be at 0 radians. And then for the negative 1, you'd be at pi radians right there. And there's your 2 answers for that one. So that one had a little bit of factoring, but it kind of had the trinomial thing, I guess, going on. Okay, next one here coming up. This one, I only see secant written once. We might be able to combine some like terms and get them together. I'm going to go ahead and do that. So I'm going to add 10 secant of x to both sides. This 2 equals 4, and then that's just really plus 1 secant of x right there. After that, I guess we could go ahead and subtract 4. That'll get us negative 2 equals secant of x. I don't know about you guys here, but I always need a little bit, I'm not used to dealing with secant. So what I'm going to do is do the reciprocal function. We say if we want here, we could do cosine of x, and then that's going to be the flipped version of your secant function right there. So I'm going to say that that is negative and then 1/2. Okay, and that's kind of how you, I guess, undo that right there. So now that we have it in terms of cosine, that's a little bit easier for me to find on the unit circle. So the cosine of what angle gets us negative 1/2, that's going to be at 2 pi over 3 radians and then 4 pi over 3 radians as well. And once again, if you wanted to do the infinite number of answers, just put plus pi, 2 pi in on those, and then you'd be good. Alright, so next one here, this one's actually a little bit tricky here at first. When you look at it initially, a lot of people might say, well, hey, maybe change the sine and cosine, and you might be able to get something to work like that. This one, you have to kind of use this weird strategy where we're actually going to square both sides. Okay, it actually really looks close to the Pythagorean identity, but unless it's squared, can't really do much about that, but I can square both sides. So let's see what happens when we do that right there. So that'll be secant squared of x. The right-hand side, you will need to FOIL out tangent x plus 1 and then tangent x plus 1. That'll be tangent squared x. You'll do tangent x, but then another tangent x. So really, you're going to have like 2 tangent x. And then the last one will be plus 1. Now, you might be looking at that and say, well, that doesn't really get me anywhere. But one thing we can do after that here is you can actually change the secant squared of x right there. You can actually change that and use one of your Pythagorean identities. We can say that that's the same thing as 1 plus tangent squared of x. And then what's convenient about that is you already have a tangent squared x on the other side, which you can actually cancel out with subtraction. And then after that, I guess you could subtract 1 from both sides. Those would cancel. So really, you got 0 equals 2 times tangent of x right there. Divide both sides by 2, and now we need to figure out at what angle do we get tangent, or I guess I should say tangent of what angle gets us 0 right there. That'll happen, I think, at 2 places here. That'll happen at 0. And remember, tangents typically the y value over the x value on your unit circle. So that would be at 0 right there because of the 1, 0, and then at pi as well because of the negative 1, 0. And those would be your 2 answers right there. So kind of a little bit of a tricky one there on that. So anyways, that's that. Alright, so next one here, what makes this one kind of tricky here. So obviously you got the 2 out in front here. You're going to have to do some type of factoring, but then also you have mixed trig functions. So what we're going to need to do here on this one is actually we're going to do a Pythagorean identity right here. Cosine squared is the same thing. I think that's the same thing as 1 minus sine squared. So that's going to be my first little thing right there. And change that. Now you still have the minus sine x that we're going to drop down in the minus 1. Okay. Next, I'm going to distribute the 2. 2 minus sine squared. Actually, it's 2 minus 2 sine squared of x. And the minus sine of x minus 1. And then you can go ahead and combine your like terms right here. Then the 2 and the negative 1 will be 1 minus sine squared. I'm sorry, 1 minus 2 sine squared of x minus sine of x. And then after that, I'm going to get this set up to where I can factor it. Some of y'all might choose to skip here a few steps, but factoring gets a little bit tricky when the x squared term or the square term is negative, so I will go and divide by a negative 1, and that'll flip all the signs around. So a lot of manipulation. Some of y'all might skip a step or two there, and that's totally fine if you do. But what we're going to need to do is off to the side, we need to figure out how this factors 2x squared plus actually 1x, and then minus 1 equals 0. And the way I teach factoring here with this here is with, I call it divide and slide. You put negative 2 up here, 1 down there. You put negative 2, you multiply the two numbers. It's the a times the c value of that quadratic. But anyways, numbers that multiply to negative 2 and add up to positive 1 would be 2 and negative 1. And you write x plus 2, x minus 1, and you divide both of those by the a value out in front. I call it divide and slide. Many different ways to factor, though, you can do with grouping and some just guess and check, I guess. Anyways, that's how that factors. So I'm going to transfer that over here and just think in terms of sine and cosine. So the first one you can write as sine of x plus 1, and then the second one would be 2 sine of x minus 1 equals 0, kind of like that. And then after you're done with that, then you can actually go and set your factors individually equal to 0. Sine of x plus 1 equals 0. 2 sine of x minus 1 equals 0. So the first one is sine of what gets you negative 1. And then this next one is sine of what gets us 1/2 after you add and divide. Okay. As far as the first part, sine of x equals negative 1, I think there's only one value for that. That's going to be 3 pi over 2. And then sine of what gets us 1/2. That'll happen 2 times at pi over 6. And then also 5 pi over 6. So those will be your 3 answers there on that one. So watch out on that one. A little bit of factoring with an a coefficient out in front. So a little bit tricky there on that one, but once you get it set up, it's not too bad. Also, yeah, it also used that Pythagorean identity there, so that's a good strategy if you got a mixture of things. All right, this next one here is dealing with cotangent of something right here. So it's pretty straightforward here. You just go cotangent of x and then equals negative root 3. I'm typically used to dealing with tangent. So I'm going to go tangent of x, and then we'll flip that. That would be negative, and then 1 over root 3 like that. Notice how I put the negative kind of to the left right there, not in the top or bottom, because I don't really know where that negative truly is going to go. It could go in 2 different places. And I would not actually rationalize that. What I'm going to do here to help myself find these on the unit circle is put those 2 over 2, and then we actually have x and y values that are typically tied to 1/2, and then the root 3 over 2 right there. So let's do some thinking here. I don't have a unit circle in front of me and winging it, so let's see here. Y values of negative 1/2, or really it doesn't matter where the negative, I guess it's, here, let's do this here. Going blind here without a unit circle. So it's negative, so it's not going to be in this quadrant or that quadrant right there. So let's see here. The y value is 1/2. The x is root 3. So I think the x is root 3 over 2. I think that's going to actually be at 5 pi over 6. And then the other one would be down here somewhere. So I think that would be 11 pi over 6 right there. And yeah, that should work out right there on those. Sorry, didn't have that one filled out in my notes. So, but yeah, anyways, make sure I would not rationalize. I guess that's kind of the big idea on that one is don't rationalize that one. Just go ahead and put them over 2's and then you should be good. Okay. All right, so this next category extends this concept here a little bit. This has kind of got like this weird little idea here. So when you do sine of 2 times an angle, basically you're going to have more possibilities that you could have for answers, actually. You're actually going to have, since there's a 2 out in front, you're going to have 2 times the number of answers that you're typically going to have. So the way I kind of like to do this here is maybe like call it sine of like something else here. I'll call it u, I guess, and then figure out when that happens right there. And then we'll replace the u, the 2x in here in just a second. So we'll just, think about those angles that work out right there for that. Sine of what gets us negative half. Those are going to be in the bottom quadrants there. I think that's 7 pi over 6. And then also 11 pi over 6. And then since we had a 2x there, we're going to say 2x is equal to 7 pi over 6. And then also you could write 2x is equal to the 11 pi over 6. Right there. Okay. Now to go and solve for x here, instead of saying divide by 2, I'm going to encourage you guys to say multiply by 1/2, and then you don't have to worry about the keep change flip. So that's going to get us x is equal to 7 pi, and then over 12. Obviously, something not on the unit circle. If we do those same steps here on this other set right here, this would be 11 pi, and then over 12. Now, typically, they'll ask us to put all of the answers from 0 to 2 pi more times than not. So I'm going to go ahead and continue that. If they don't, since the period is changing here, the period is now, remember back from the last unit, period is typically 2 pi over your p-value, which is pi. Basically, you would need to go and add pi n to each of these numbers here. Now, if I ask you all of the answers from 0 to 2 pi, which is typically what we're going to do here, we'll go and think, okay, pi n, let's say we need to add like a pi, I guess. What we would do is write that as pi over 1, and then get a common denominator with that. That'd be 12 pi over 12. And we can go actually do 7 pi over 12 plus 12 pi over 12. Basically, you're going to keep adding 12 pi until you get to something bigger than 2 pi. It's like adding a 12 pi right there. 12 pi over 12, I guess I should say, would be 19 pi over 12. 12, if you do like 19 over 12 in the calculator, that's going to be a number a little bit less than 2, or the 2 pi. Yeah, that's about 1.58 pi. So that one is not greater than 2 pi. That's going to be part of your answer here. You're going to say 7 pi over 12. Got the 19 pi over 12. If you go and add another 12 over 12, that's going to get you, 31 over 12 pi. And 31 over 12 is going to be about 2.58, so that's going to be a little bit too big right there. So you're only going to add 12 pi over 12. You're only going to add that once there to that one. So let's go down here and do the same thing. We got 11 pi over 12. And we add a 12 pi over 12. That'll get us, I guess, a 23 pi over 12, and that's just a hair below 2. 23 over 12 is about 1.92 pi, so that would be, if we added another 12 pi over 12, that'd be too big. So your final answers here is 11 pi over 12, and then the additional 23 pi over 12. And if you go back to kind of what I said at the beginning, you might not have caught this here. If you have a 2 out in front here, there's going to be 2 times the number of answers to this, typically. That's a kind of a good rule of thumb to count up and make sure you have the correct number. Okay, so on this one here, I'm going to start it out the same. Some people will skip right in this here, but I'll call it tangent of something. Tangent of u equals 1. That's going to happen at a few different places right here. So that'll happen at... let's see here, 1, that would be pi over 2, I think, or pi over 4, I'm sorry. So pi over 4 will get you the positive 1, and then also you could do, let's see, that would be 5 pi over 4. I'm kind of doing it there in my head there for a second. So anyway, since you have 1/2 x is equal to that, we're going to need to now, instead on this one, we're going to need to multiply. What happened there? I don't know why that lost that. You're going to need to multiply both of these here by 2. So if we multiply both sides here by 2, this will be 2 pi over 4, which is pi over 2. So that's one of your answers right there. This other one, watch this here. This will be kind of weird. This will be, let's see here, 5 pi. Actually, I'm sorry, 10 pi over 4. Which actually, when you reduce that there, that'll be 5 pi over 2. That is already bigger than 2 pi. So in a way, we kind of toss that answer out right here. So this one typically has 2 answers, since you're doing half of your answers right here. If you normally have 2 answers, now you're only going to have 1 answer right there. So that one's just going to come out to just the pi over 2. Now, if you wanted to do the infinite number of answers, the typical period for tangent is pi, but then you do pi and then over the b value 1/2, which actually comes out to 2 pi. So if you want to find the infinite number of answers, instead of adding pi, you'd add 2 pi in each time. But they did ask for 0 to 2 pi there, so just the pi over 2 would be good there on that one. So that one had half the number of answers. Okay. Now this last one here, it's pretty similar to the previous, or the very first one that we did, just a different spot there. So let's see if we can figure out this one here. So I'm predicting here, if there's a 3 on front, we'll probably have 3 times the number of answers. So let's see what's going on here. Tangent of u and then equals, I guess, 1 on this one. It's actually going to be some of the same numbers here. It'll be pi over 2, I'm sorry, pi over 4. Got that last one stuck in my head. And then 5 pi over 4. Okay, and then we'll do 1/3 x and then equals pi over 4. And then 5 pi over 4. And kind of like what I said on that previous one. Actually, hang on, I wrote it down wrong. It's 3x. A step ahead of myself. What we're going to do, like on the previous one, on two problems ago here, is you're going to multiply by 1/3 right there. Now it gets you pi over 12, and then I guess that would also get you 5 pi over 12 for your 2 main answers. Now, we need to figure out what we need to actually add on. Your period for tangent is typically pi, so your new period is going to be the pi, and then over, I guess, in this case, the b value, which is 3. So now we're going to go and take these here, and we're going to add pi over 3 until we get up to 2 pi or greater than 2 pi right there. So we're going to have to add it a few times here. I actually anticipate us adding it multiple times because you're going to have 3 times the number of answers. So I am going to kind of queue up a common denominator here. So I'm going to go off to the side, pi over 3. To get a common denominator with that 12, you need to multiply top and bottom by 4. So we're going to add 4 pi over 12 right there a couple of times. So if I add a 4 pi over 12, 4 added to 1 right there, that would be 5. So 5 pi over 12. That's not quite bigger than the 2 pi, so I'll add another one. Another 4 pi over 12 would be 9 pi over 12. And actually, you know what? Here I noticed there that 5 pi over 12 is kind of incorporated right there. So we just keep adding basically until we get up to 2 pi. And then some of them will already kind of overlap here. So let's add another 4 pi. That'll be, what is that, 13 pi over 12. That's just a hair over 1. Add another 4 pi, that'd be 17 pi over 12, 21 pi over 12. We're kind of getting into that region right there where we're getting real close to 2 pi. Next one would be 25 over 12, but I think 12 goes in 2 and some change, so we don't actually list that answer. And then if you go and add the same thing down here, you're going to get all the matching answers. So I think these 6 are it, which makes sense. Typically we had 2 answers, and now we have 3 times the number of answers. So that will be it here for today.